everyone. I'm Jeff, and I'm the CTO at a company called Contrast Security. We offer a product that supports the whole SDLC. It has IAST and RASP in a single agent, so that's a little unique. Please stop by and check it out. I'm really psyched to be here today. If you've seen me talk before, then you know that I'm all about scale. And it's not just because I'm tall. I'm actually interested in scale because every AppSec program that I've worked with over the last 15 years is struggling with scale. They've all the ones that I've seen, they're only touching a small fraction of what they really ought to be doing. And in my mind, AppSec ought to apply to all of the application portfolio, right? Not just the internal apps, but all of them. They need to be continuously monitored and protected, right? That's a huge thing. Anybody disagree with that premise, just when we're starting out here? Okay, who here thinks that the perimeter protections are not doing a great job of protecting applications? Really? I was expecting like more. Who thinks that perimeter devices are protecting applications? All right, so the rest of you are just not answering any questions. Okay, that's good to know. So if you raise your hands, then please stop talking about internal applications. If there's no perimeter, there's no internal. Everything is an external-facing application. And I really want you to think that way when you sort of think about your application portfolio. So today, I'm going to take you on a journey from really small to like the sort of the smallest application security concerns all the way to really big enterprise scale, AppSec at DevOps speed and portfolio scale kind of stuff. So for the next 40 minutes or so, I want you to forget what you know about application security. Because what I'm going to talk about is a little bit different. I have a different take on application security. I have been doing it for quite a long time. And I'm going to try to suggest a new way of thinking about the problem. So, uh-oh. Little clicking malfunction here. OK, so here's what I've seen. And maybe you guys have shared this experience, right? I've done a lot of penetration testing over the years. And what I think is weird is that almost no applications ever recognize that I'm attacking them. Right? I'm a really noisy pen tester. I send all kinds of crap to applications that are totally obviously attacks. But applications don't say, stop, the police are on the way. We've logged everything. What do they say? Yeah, or I didn't understand your request. Please try again. They want me to keep hacking. That's really weird, right? So like, to me, the simplest thing that you could do to improve application security is identify obvious attacks and block them, right? So I asked myself, I'm like, why is it that this clicker is not working whatsoever? So why don't applications protect themselves? That's strange to me. RASP is runtime application self-protection. And self-protection is a really key concept here. And so you want to ask yourself, why don't applications protect themselves? Well, there's really sort of two options, right? You can build in security, and that's really hard, right? I'm going to say after 20 years of trying that this approach is not likely to start working all of a sudden, right? Nothing's changed. I mean, this is really hard to get at scale to build secure apps. We can argue about that later. He's giving me the, I don't know. So, you could try the SDLC. And frankly, I don't care if you're measuring yourself against other organizations who are doing stuff that doesn't work. That doesn't help. There are projects like App Sensor and ISAPI out there to try to help organizations build apps that detect attacks and block them. But that hasn't worked either. Really, they're not widely adopted kinds of frameworks, although I think they're great. And so the other approach is really to try to add on security to an application, like add blocking on the outside or add a perimeter device. And I'll just say, that is never going to work either. It's very difficult to defend applications without the context of what's going on inside the application. But there is a third option. And I'm going to sort of walk you through that in this talk. I'm going to start by introducing this. This is a Raspberry Pi. Anybody played around. I'm going to hand this out. I'm going to walk out of my box for a second. So this is a Raspberry Pi Zero. You can open that up and just pass it around. It's a $5 computer. And it's amazing. This one's in a case, but yeah, you can open up that thing. But I got my kids some Raspberry Pi Zeros for Christmas because I thought it'd be fun to teach them some electronics and play around with them, and it's awesome. And then I thought, hey, what would happen if I put a vulnerable application on this and protected it with RASP? So I did that. I put a vulnerable application on here, sort of like WebGoat, and it's a simple WebGoat, and I put a RASP agent on it to protect it. Then I wired it up so that if there's, if it detects a vulnerability, this is a power supply, by the way. It's just a battery. This is the actual computer. It's got wireless connecting back to my computer here. But if it detects a vulnerability, it lights up yellow. If it blocks an attack, it lights up green. If it detects an ineffective attack, it lights up blue. And then if an attack gets exploited, it lights up red. And the only reason that something would get exploited is if the RASP is set to log mode, right? Then you get an alert that it was exploited, but it didn't actually block the attack. So I'm going to demonstrate this. Oh, I've got to exit the presentation. And I'm going to demonstrate this. So here's a simple application that's running on this Pi. And I'm just going to lean this over the edge here like this. We'll see how this works. Can you guys see the lights at all? All right, well, we'll see. So I'm just going to put in some garbage data, foo, bar, zoo here, and submit this. And you can see it detects 3 vulnerabilities in this application, right? Notice that we detected vulnerabilities without exploiting them. That's something that IAST and RASP can do. And the 3 vulnerabilities are cross-site scripting, SQL injection, and weak encryption that this page happens to have in it. And you can see there's an encrypted token there. So let's try attacking this thing. I'll put in a SQL injection attack. So I'll put in foo, single tick, or 1 equals 1, and submit this. And we get a warning screen. I'll zoom out here. So the RASP agent identified this attack in real time, blocked it, and defends this. And you see that it also detected the vulnerabilities as well. I'll try an attack that won't work here. This authentication token is encrypted. It goes into the database, but only after it's been encrypted. So when we put this in, the agent, did I get that right? Tick or. So this one gets encrypted before it goes in the database. So it's what RASP would identify as an ineffective attack, right? Because the data was encrypted before it went into the query. So it's not an effective attack. And then I've got a path injection flaw here. The vulnerability is just reading from an untrusted source. So what kind of attack should I put in here? Like this lets you request a file, and it prints the contents of that file. So if you were attacking this, what would you go for? OK, good. So let's do that. So let's go .. /etc/password. And this one, I have the defense turned to log mode, so you see we get a bypass attack. So really the point I'm trying to make here is that RASP is incredibly powerful. It can apply to any application at any size, small all the way up to the largest enterprise application, and it can build defenses in. So what I'm going to do now is I'm going to tell you how that actually happens. So instrumentation is a really powerful idea. It applies to basically anything that's complicated. You can build instrumentation into it so that it then can monitor itself or affect the behavior of the thing. So industrial factories have this. You monitor temperature and sound and vibration and all sorts of stuff. And it's really critical to running a complex operation. Well, our software is probably the most complex thing that's ever been created by man, and we need to instrument it in order to monitor how it behaves. But we don't, right? There's almost no instrumentation built into most applications. So RASP is basically instrumentation for security purposes, right? And there's a few kinds of instrumentation. The simplest kind is just instrumenting the source code. So this is an example of adding some code to the MySQL JDBC implementation, right? So you go to the methods that would be susceptible to SQL injection, and you can weave in a couple of lines of code that say, hey, warn me if anybody uses this API. In this case, give me the whole stack trace so I can see where it got called from. And if you added this to your database drivers and then push that out as part of your standard application stack, in a matter of hours or days, you could know everywhere in your company where you're potentially susceptible to SQL injection. Now, the problem with this is that it's not very accurate, right? You'd get a lot of places that aren't vulnerable to SQL injection. This is just a simple example to try to get you to understand how instrumentation works. So this is just a simple static method call, very safe, doesn't affect the application at all. It just gathers a little bit of data and reports it to you. So that's doing it in the source code. Then you got to recompile it and redeploy that. You can also do binary instrumentation. So there are a lot of tools for this out there. Things like ASM and B-cell. B-cell is actually built into the Java virtual machine. There's ones for .NET and other languages. This is used really widely for measuring performance, like memory use and bottlenecks and things like that. Companies like New Relic and AppDynamics use this for performance monitoring. It's used to weave in extra logging into applications. Proven technology, very safe, and you're almost certainly using this already in your enterprises because it's built into tons of libraries like dependency injection libraries and so on. So binary instrumentation weaves those same changes in, it just does it into the bytecode, right? So then you've got modified jar file. The benefit is that you don't have to change the way you're building and testing your source code. You just weave in these changes later. So then the next level of this is dynamic binary instrumentation. So this happens at runtime, and this is where the runtime part of runtime application self-protection comes from. This instrumentation happens as the application runs. So you see here the binary code from your disk gets loaded into memory. And you can hook that process to modify those binaries, to do the instrumentation on those binaries as they're loaded into memory. Again, it's the same instrumentation. Libraries and so on is still very safe. It's just done as the code gets loaded. And in Java, you can use the Java instrumentation API for this. In .NET, you can use the profiler APIs for this. Most modern platforms have a way of doing this. And it's really powerful. It allows you to weave in security sensors and actuators into your applications so that now you instrument all your code for the things that you want. And because it's dynamic, you really don't have to change the way that you build, test, or deploy your code at all. You just deploy it the normal way, and all this instrumentation happens at runtime. So that's the essential ingredients for RASP. Now, the question is, what do we instrument in? Well, RASP, the way I think of it is RASP starts with this sort of ordinary, insecure application, the naive application that most of us write. And at runtime, as the application loads, RASP weaves in new security capabilities into your application. And really, there's not any limit to what it can weave in. I'm going to talk about some of the things that RASP does today. But the future for this is really very bright. I'm very excited about what we can do with this. But once you do this, then the application is self-protecting, right? And that protection goes with the application. Wherever you deploy this application and the RASP agent, the protection goes with it, right? So you can move it from your internal network to your external, I just said internal and external, but move it out onto the internet, move it into the cloud, move it into a container, it doesn't matter. Wherever the agent goes with the application, and it's self-protecting from that point. So here's what we weave in. Sensors are basically passive callbacks, like the one that I showed in that MySQL driver, to just gather some information from your running application. You might want to gather information about the things that you are security relevant, right? You might gather data from what we call sources, like request.getParameter. You might want to know where those calls are made. Or syncs, like the SQL one we saw, or XSS syncs, or XXE, any of the traditional vulnerabilities, anything related to that kind of stuff. You might want to gather data from the HTTP request. You might want to gather data from the configuration files. Anything that the application has access to, instrumentation can put a sensor on it and gather that and make it part of your security analysis. This is what I mean by context. If you want to identify vulnerabilities and attacks accurately, you've got to have that context from the running application. So the other thing that we weave in are what I call actuators. These are active callbacks that allow the instrumentation to do something within the application, like block a request, or add logging, or add a security header to a HTTP response. Those kinds of things can also be done with instrumentation. So we got sensors and actuators. The agent handles them, and then the feedback goes back to the agent, right? So when the sensors run, they provide data to the agent. The agent can communicate that out to, say, a central console somewhere, sort of for command and control purposes. Everybody with me so far? Okay, so that's instrumentation. It's very powerful. I think I mentioned a lot of these things. One thing that I think is interesting I didn't mention was that security instrumentation can access all the code, the binary code itself, so it can do things like static analysis for certain kinds of vulnerabilities. It also has access to all the libraries and frameworks in the application and exactly how they're used by the application. And so we've been doing some analysis of this. It's actually pretty interesting. Only about 7% of the library code in your application ever actually gets used. Most of it is there because of compile time dependencies or just extra methods in libraries that you're not using. But people talk about insecure libraries. We added it as A9 to the OWASP top 10. But until you really study what's actually happening in your application, you could be fixing and replacing libraries that you're never even using. Spend a lot of time on that. So in a way, security instrumentation can provide a lot of the benefit of static analysis and dynamic analysis and things like WAFs and IDS, IPS, and all deliver it through an agent to inside the application where it can happen. So here's a little interesting sort of data visualization here. This is an XSS in a Spring app. It's incredibly simple XSS, right? Just a few lines of code that introduce this. But what it shows is what I call a cluster bomb effect of string handling in most modern frameworks. So when a string comes into your application as part of an HTTP request, for instance, strings are immutable in languages like .NET and Java. So every time you add something to a string or split a string into pieces, you're really creating new strings. And then they get processed. And so when I think of it like a cluster bomb, right? Like the thing comes in and it explodes into a bunch of parts, and then each of those goes processing along and explodes into a bunch more parts. And they're all potential attack vectors, all of those string parts. So what this does is essentially trace. You can see the HTTP request down here at the bottom right. And then it traces the flow all the way through where all those little pieces of the cluster bomb end up in the application. And the reason I mention this is if you want to analyze the security behavior of an application, you have to be able to see this level of detail. This is very difficult to generate any other way than watching the application run. It's invisible in the source code, for instance. Very difficult to sort of reverse engineer this and understand it. So here's how RASP might block an attack. So let's imagine the attacker over here sends in an HTTP request with a SQL injection attack in it, like I just did on the little Raspberry Pi thing here. The attack comes in, and there might be some sensors in the controller that tell us, hey, a new HTTP request came in, so we're going to add that to our security context down here as part of the agent. And then as we go through the processing of the application, different events will fire. Things that we've instrumented will fire events and add them to the security context. So we can see, hey, here's how this data flowed through the application. Here's the validation and encoding that went on that data. And we just track that all the way through. Eventually, in this case, that data ends up in a SQL query, right? We finally got to the SQL API, and we notified the agent, hey, here's a new query that's going to the database. Well, the agent can then analyze this and say, hey, you know what? When we look at that query and we see exactly where the attacker's data fit into that query, when we analyze it, that attacker was able to change the meaning of that query. What they changed in the query modified the meaning that it's an attack. So then we know for sure that it's an attack. And this is really the difference between sort of perimeter defenses and RASP, is that RASP has inside access to what's going on. It has all the context. So it's extremely accurate when it identifies attacks. And in this case, it can block the attack. Just like I showed you on this thing, it can do whatever you want the application to do in that case. Put up a warning or call the police or whatever you want it to do if you're actually being attacked. This is the essence of being a self-protecting application now. So I wanted to compare WAF and RASP. And yes, RASP can block attacks like a WAF. But I don't really like that comparison because, as I'm going to explain, RASP is really much broader than just the WAF use case. In this case, I think there's some advantages to RASP. So really, there's 3 problems with WAF. The first one is that WAFs are bottlenecked, right? If you've got to run a whole bunch of users through one WAF and support a bunch of applications, then as the load goes up, the performance penalty is going to increase on the WAF. RASP is distributed. So every application protects itself. Every instance of every application protects itself. So the defense is done in a distributed fashion. You don't need any extra box to do this. The next thing is WAFs have no context, right? So when they see the attack, all they see is, or 1 equals 1 on the wire. That might be an attack, but it absolutely might not be an attack. I know in the past some WAF rules that just blocked every request that had the word select in it. Well, that's a problem if you're writing an email message that has the word select in it and it gets blocked, right? They don't have enough context to accurately block. And so that's why, if you have a WAF, you probably also have a bunch of people that are managing the rules on that WAF and updating it every time the application changes. RASP doesn't have that problem. And the last thing is something called the impedance mismatch problem. You guys familiar with impedance mismatch? Yeah, the idea here is that the data on the wire might be encoded in a bunch of different ways that the application sees differently, right? By the time the data gets up through the stack into the application, it might have been decoded in a bunch of interesting ways. RASP views the data the same way that the application sees it, right? So it doesn't have to have a separate set of decoders and try and guess the way the application stack is going to decode it. It's going to actually use the same data that the application is using. So it solves that problem. Another advantage of RASP is that it can, yeah, you got a question. Yeah, let me table that for just a second. I got a slide on performance in just a second, okay? I got some numbers, so I want to get your question, but let's just wait. So protecting services is really difficult. We see a lot of development going on in services and APIs. All your mobile apps connect back to a service. A lot of even regular web apps these days, they're really just JavaScript front ends that connect back to services. So securing services is really important. Problem is, SAST, I just did a talk at LastCon about how well SAST and DAST support web services, and the results are pretty shocking. They don't really work on services. Also, WAFs don't work on services because it's really hard to understand the syntax of a more complex API like that. RASP doesn't have that problem. RASP is inside the application, so to RASP, a JSON request or a XML request, it looks basically the same, right? RASP tracks the data from the XML file and tracks it through the application to where it goes, and it can identify vulnerabilities and attacks the same way that it does for regular HTTP requests. So here's the performance slide, right? So hopefully I addressed some of your questions. So RASP is really fantastic for performance, in my opinion. Typical processing on WebGoat, we used as an example, we loaded it up, and RASP adds 50 microseconds for normal traffic. That's a 20th of a millisecond per round trip request. So probably faster than if the developer had written validation into the application. RASP is really, really fast because it's really relying on a lot of work that the application platform has already done, right? If you do this in a WAF, you've got to receive all the parts of the HTTP request, assemble a TCP stream, and then walk it up the stack, parse the HTTP request, and then send that back out on the wire. It's a whole extra hop. RASP doesn't have the problem, right? It's just straight in, we're using the data exactly from the APIs that the application is using. So with mixed traffic, that's sort of like half and half attack, like a medium level attack. Load goes up to 170 microseconds, and even really heavy attack traffic, only 230 microseconds. So a quarter of a millisecond. It's really, really fast performance here. Did that help answer your question? OK, good. Yeah, so there is a penalty, absolutely. But I think it's important to understand that RASP is really efficient, and it does it in the way that your coders should have done it if they had written the attack detection and prevention into the application itself. And just another thing on sort of scaling and performance is that RASP works on applications of any size. I demoed it on a tiny little application here, but we've used RASP on applications that are 20 million lines of code. Because it's just sort of woven into the application as part of the infrastructure, it doesn't add a lot in terms of performance on even a very large application. OK, so I wanted to talk about the Java deserialization flaws. Anybody familiar with this? It's sort of recent attacks. So there's a couple folks. So I think this is really interesting, right? So many applications use serialized objects to communicate between client and server. And basically, this application is waiting for a serialized object to come in. And when it comes in, it's going to deserialize that. And it's got a couple of fields, the name field and the record ID and the owner. And what's really important is the type here. So the way that the parsing works is Java accepts these objects and then looks in the stream for what type of object to deserialize this into. Well, that's a problem, because now we got the bad guy over here, and he creates his own serialized object. There's a tool called Why So Serial, like Why So Serious? Why So Serial that'll create these malicious serialized objects. And in this case, he's using a gadget called Acme internal type. And you can use any type that you want that's available in the target platform, in the platform of the target application. Because of the explosion of libraries that has happened over the last 10 years or so, those platforms are incredibly rich. There's huge numbers of classes available that the attacker can try to misuse. And so there's a number of these gadgets that actually take data and then turn it into running code. So in this case, you can see he's found one called Acme internal type that has some data objects in it, the Java lang runtime, that's the object, the method to invoke, and the command to pass into that method, right? So now what happens is when the attacker sends that malicious object to the vulnerable application, it deserializes it. It creates an instance of this Acme internal type. And importantly, it calls the constructor on this object, right? So it invokes the constructor, which is now, this data has been filled in. And if that constructor invokes the method here via reflection, then this command will run. And you pop up a calculator or whatever you're going to do, right? So this is a really powerful attack. And it turns out that these serialized object interfaces are pretty common. So there are a bunch of major products that take deserialized objects or take serialized objects and are vulnerable to this. The challenge is it's really hard to find these in your portfolio. Like you say you got 500 applications. How are you going to go find all the places where you accept untrusted data and try to deserialize it? It's tricky because it's all custom code everywhere. So we actually released a open source RASP agent for this. And RASP is really uniquely well suited to deal with this problem. So what this, we called it contrast RO, R-O-0, because every Java serialized object, if you base 64 encode it, it starts out with the letters R-O-0, okay? So that's why it's named that. But what the RASP agent does is you can just deploy it on your application stack, and it hooks into the deserialization process and looks at the objects that are trying to be deserialized. If they're on the blacklist, which it comes with, then they get blocked. You can change over to a whitelist, which would be better if you know that your deserialized objects are only going to be instances of string and vector and stuff like that. Then that's a little safer way to go. But we'll keep that list up to date. But the point is, you could add this to your stack and prevent deserialization attacks everywhere in your enterprise really easily. OK. So let's zoom out a little bit, right? So I want you to think about RASP. Now we're getting to from the other end of the spectrum. I started really small. Now I want to get really big, OK? So I want you to imagine RASP as a security API into your applications, right? So imagine that you had a way of connecting with your applications and adding monitoring, adding policy enforcement to your applications dynamically. So here you can imagine, let's say you want to know all the places in your enterprise where you're using single DES. That might be something interesting to know, right? Well, with RASP, if you deploy a RASP agent as part of your standard application stack, now you have that capability. And you can ask your application portfolio, hey, who's running single DES out there? And get feedback back on that. We've never had this capability before, right? You can do things like use RASP to turn off XML doc type processing. If you do that in all your XML parsers everywhere throughout your organization, you've just defeated XXE everywhere, right? That's powerful. Maybe you want to set X-frame options on every HTTP response that goes out. You could do it with a WAF, but it'd be really painful. This is a fast way to do it from within the application themselves. Things like this, like adding a header, are zero performance hit, right? That's an instantaneous call to add a single header to an HTTP response. So you could make a solid protection against clickjacking everywhere in your application portfolio really quickly. And a bunch of other use cases. Like you can imagine basically doing anything from a security perspective. So I sort of think of RASP as an adapter that we have never had in security to know where our applications are, what's in them, what vulnerabilities they might have, what protections we might want to put in place. So if you think about it, it's actually establishing what I'll call an AppSec control plane. And there's been, in the network world, there's been network control planes for a long time, right? You have a single place where you can go to control endpoint protection and firewalls and things like that. We have that visibility on the network layer. But right now, our applications are out there in the wild, wild west, right? You have no way to communicate with them, no way to know what they're doing. RASP can establish this security control plane across your enterprise. And that's really doing application security at DevOps speed and portfolio scale, right? This is all real time. So I want you to sort of think for a second about what would happen if another deserialization bug came out tomorrow, right? How long would it take you to protect your enterprise against that flaw? And what would you do? Would you start trying to find it with static? Well, you'd have to go run through all your whole portfolio with your static analysis tool, right? That could be years. And then you'd have to go fix it, and there could be another one the next day, right? So we need to change our response paradigm from years for new vulnerabilities to minutes, right? And we can do that. It's possible, but we need to enable our applications to be self-protecting. So one other point that I think is interesting here is, the RASP-enabled application can move. Once you've set up the protection and you have centralized control over policy, it doesn't matter where your application is deployed. You've got it on your internal network and you've got RASP rules set up. You can move that application to the cloud and the same policies apply. Or you could apply a different set of policies for things that are deployed in the cloud. And I think that's really powerful because applications do move. So these things are possible today. We can weave these kind of capabilities into applications, things like attack detection and prevention, full command and control over applications, even simple things like just figuring out what's in your application inventory out there. The app identification problem is huge for some companies, but if you build RASP into your application stack, then you've turned application security inside out, right? I know a bunch of you work for AppSec groups, and you've got to go out to each development team and say, hey, please, could we test your application? That's a pain. With RASP, you turn that relationship inside out, right? Now the information is coming to you. So you know where the applications are, you know what's in them, their basic architecture, and you can move on from there. Virtual patching is really powerful. If a new attack comes out, it's easy to deploy that kind of virtual patch. Actually, that's the use case that I always liked about WAFs, is that if there's a new attack that's really dangerous, you could push out a virtual patch to block that attack based on some signature very quickly across the infrastructure. That's a use case that every application needs, because there's going to be another attack tomorrow that nobody's ever thought of before, and you're going to want to protect your whole portfolio. It's just a pain to do it with WAFs, right? This can do it centrally and push that virtual patch out quickly, and then you can figure out what to do with it in your leisure. We've done this with libraries as well. So if there's a new CVE comes out on Struts or Spring or something, you can push out a virtual patch that weaves itself into the library and allows you to continue operating with that vulnerable library. Anybody here still using an old version of Struts or Spring anywhere in their enterprise? So everyone is, because it's really hard to replace it, right? I had one client come to me and say, every time there's a new Spring vulnerability, we've got to go fix 1,000 applications. And it costs us $10 million to upgrade, retest, redeploy, and it could happen again tomorrow. So they really love this idea of weaving in these virtual patches into libraries. I think the idea of self-inventorying and self-profiling is really important, because there's so many applications out there that nobody knows they're really running. And even security logging. This has been a challenge for us for a long time. Has anybody ever looked at log files? Is there any really great security information in there? A lot of stack traces, a lot of debug information, but is it a great security log? No. But we can weave that in with RASP and improve logs so that you get actually really good logs. And then everything downstream benefits, right? Take those better logs and feed them into your SIM, feed them into your fraud detection, feed them into your SOC. They can do better job of identifying attacks across your enterprise because of RASP, because we can make those logs better. So that's what I wanted to come here and talk about. I'd love to take your questions and comments on RASP or anything else, actually. Yeah.
Just a question about the data that's being logged, perhaps it contains some sensitive information. Would that be something that an attacker can leverage to attack the application itself?
Well, two things. So, what specifically gets logged depends on your RASP implementation. And most of the stuff that RASP is going to log, like vulnerabilities and attacks, is already sensitive. Right? You don't want the bad guys knowing where your vulnerabilities are, knowing what attacks are happening on you. But it is true, you could end up logging user data like credit card numbers and social security numbers, and so you should probably have some kind of masking in your RASP implementation. But I'm not talking about any specific products here. I'm really talking about the class of products that is RASP. But I wouldn't recommend just making that RASP data open to anyone. That's private. That's just, if you look at the control plane, it's like these people up here that have, I can't get my, these people up here that have a reason to know about the application security information there. That's who would have access. Yeah. Sure, but again, that's product specific, right? And if you're talking to vendors, you should be really clear about, what attacks do you care about, what vulnerabilities do you care about, and what does the product that you're using actually work on? There's a variety of products out there with different approaches to this. Yeah.
Could you please describe a little bit about the dashboard after gathering all the data that you present it to us?
Yeah. So the RASP dashboard, all the agents are communicating back to the RASP dashboard, right? And again, it's product specific, but what you're looking for is a way of visualizing all of that data in a way that really is useful. Now, I believe that bringing vulnerability data and attack data together in the same dashboard is really, really useful, because it lets your developers know what's being attacked, which is pretty important information if they got to prioritize stuff. And it also helps you know where to, knowing where the vulnerabilities are will help you know what attacks are really important. So I think that's sort of an evolution, is we'll see unified dashboards that, if you think about it, the history of AppSec is split between dev and ops, right? On the dev side, there's pen testers and static analysis and DAST and code reviewers, and I spent a lot of my career over on the dev side of things, finding vulnerabilities and fixing them. And then there's a totally separate side that's ops. It's the attack blocking, the production side of things, where you're identifying attacks and blocking them. And to me, they're the same problem, really. I mean, if you think about a vulnerability, it is like an open window, right? And an attack is a guy climbing through that open window. So they're very related. The path through the code is almost identical for vulnerabilities and attacks. And so it's really weird that we have these two whole classes of technologies, and sort of never the twain shall meet. But I believe RASP and IASP coming together in a single agent is the way that this will evolve. It's the same technology used for two slightly different purposes, and it just makes sense to put them together in the dashboard. And it's really the way that development is going anyway. The software development's heading towards DevOps, and we can't continue to be two communities of dev and ops. We need to have the same tools on both sides of the equation. So hopefully that answered your question. I would look at the different vendors' dashboards and see which ones look like rich, useful information that you can get security value out of, and which ones are just log files.
How can we actually use RASP? How can we use RASP for native mobile apps vulnerability validation?
Yeah, RASP is a platform-specific kind of technology, right? So you need to talk to your vendor about what applications you want it to work on. There are RASP implementations for almost every platform out there, but not every vendor supports every technology. So you just have to talk to them. But I fully believe that in the next 5 years, every application is instrumented for security, because it's so powerful, and it just solves a lot of logistical issues around AppSec. Yeah.
Thank you. That's actually a great segue. If we all could have a suddenly RASP-enabled portfolio, as the slide describes, in 1 year, 5 years, what's the next thing we worried about? Is it who is attacking? This looks like a great way to block the actual attacks, but then what do we care about next?
Yeah, so to me, the way security works is, you have a model of how you want security to be, and you can set up RASP to evaluate yourself against that model, right? And there may be deltas that you can work on to improve your performance against that model. But what you work on going forward is how to improve the model, right? That's understanding the threat, thinking about what new attacks they might have. So, AppSec is very reactive. We discover, Jeremiah's here somewhere, he discovers clickjacking in, 2007 or 5 or something. I was at the talk when he talked about it. And then, we're like 8 years later, and there's still a ton of applications that don't take the simple precaution of adding X-frame options header to their application. It's ridiculous. We can't wait 8 years. I mean, we're at like 25 years and counting on buffer overflows, almost, 19 years on XSS and SQL injection. Like, it's crazy. So, we've got to do something to get in front of that a little better. And I think this will help, right? This will allow you to get a handle on the vulnerabilities that you got. Like, if you've got a legacy portfolio full of a bunch of flaws, you can get in front of it with RASP and then be strategic about what you want to focus on going forward. You know, I would suggest spending time doing some threat modeling. And you know, that's me. But this frees up your security experts from being XSS zombies, right? I know companies that have teams of people that all they do is review the output from static tools and take it to the developers and say, hey, could you fix this? And they end up just being, you know, XSS machinery. That's not useful. We got a limited number of AppSec people in the world, and we need to use them strategically on hard stuff like access control, authentication, better encryption. Those kinds of things are, you know, not the simple stuff that we need to automate and get out of the way with automated protections. Great question, by the way. Anybody else? Yeah. It's a good question, and it's possible, right? My suspicion, though, is that if you give developers instant feedback as they're testing locally, and they type in an XSS flaw, and something in their environment goes beep, you know, they get a notification or an alert or a compiler warning or whatever it is, my suspicion is that they're going to fix it right there and turn over clean code. But look at the job of a developer right now. They write code, and 6 months later, it goes through some static thing, and they get back a report that doesn't have just the flaws that they introduced, it's got everybody's flaws in it. So they got to search through 5,000 vulnerabilities to figure out which ones apply to their code, then track it down to figure out what line of code, if it's a real vulnerability, and what they need to do to fix it. It's just not reasonable, right? In most cases, those guys are gone. They're working on the next project. And this thing just goes to some maintenance developer who's comped on how many flaws they can fix in a day. So they fix it wrong. There's a 40% failure rate on security fixes. Even when they're given the full details of the flaw and told exactly how to fix it, 40% failure rate. That's no good, right? So we need to get instant feedback. I didn't understand the question. Oh yeah, so the instrumentation is actually really easy. Different vendors have sort of different approaches to this, but typically it's a really small agent. So, you know, Contrast Agent is a 3 megabyte jar file for Java. It's a small installer for the .NET platform, and Node.js is another small install. You know, it's tiny. The power comes because that tiny thing has tentacles that reach into and instrument the whole application, right? So it's like it's like an octopus with a whole bunch of taps into your application that pull out the data where it's needed. Okay, I think that's it for questions. So, you know, hey, I'm around. Please stop by the Contrast booth if you're interested. I'd love to show you how we do RASP. And if you want, you can enter. We got a raffle. You can win a cool something. And we'd love to talk to you. So thanks a lot, and I'm easy to find.